Hello, Ben.
Hello, John, and welcome back to Rustacean Station.
Thank you. It's I guess welcome back is appropriate for the audience, but for us, we've just been sitting right here waiting patiently since 151, haven't we?
My legs are asleep right now. They are fused to the floor. My skin has grown over the chair. I will need an ambulance or some kind of, at least, knife or scalpel to ever leave this spot ever again.
Yeah, I'm very glad that I have like a swivel chair at least, so I've been able to rotate, but that's the extent of it really for me.
Mm-hmm. I'm actually not even in my house right now, so I'm actually reduced to begging from passerby for food and water. So, but
Yeah,
we do it all for the viewers or the listeners.
Yeah, I managed to like break a window so I can scream outside to get people to bring me stuff. But I've had mixed reactions.
Anyway, let's do what we came here to do and have been here to do. Talk about the next Rust releases, 1.52 and 1.53. These two aren't super big, but we also, in between those two releases, the Rust team has released a sketch of what the Rust 2021 edition will feature. So we figured we might as well go over that as well, and that should bring us to a nice full-length episode. What do you say, John?
I'm very excited. I think we should dive in.
Let's dive in. So the first thing on our list here for 1.52, I don't have anything. There's not many big features. For me, I have written down some of the stabilized new things on the chair type. Is that previously, I've gone over this so many times before, I'm not going to reiterate, but as of Rust 1.0, many things that should reasonably be associated consts and functions weren't, because those features didn't exist back then. And so very slowly, parts of Stood are being migrated here many years later to finally have various things be living where they belong as associated functions and const, and chair is the beneficiary in this release. Some associated constants on there, some new functions, so you may no longer need to import the chair module from Stood. It should be much nicer, much more intuitive. How about you, John? What do you think is the biggest feature of this release?
So I think there are two things that made me excited. The first one is sort of the headline of 152, which is that now if you finish compiling your project with like cargo check or something, and then you run cargo clippy will actually run and actually give you output. This has been a constant headache for so long, where if you ran cargo check and your thing ran correctly, then running cargo clippy did absolutely nothing. And so you had to make this arbitrary change or like touch one of your source files just to run clippy. And finally, with 152, you don't have to do that anymore. It makes me very happy. But there's also a stabilization that I think is really cool, which is the stir type now has a split once method. And this comes in really handy if you have a string and you just want to split it by some delimiter, and you want to get like what was before the delimiter and what was after. Because previously you only really had the split method, which gives you an iterator over all of the split pieces. But it's just so common that you just sort of want the left and the right. And you could do this with like split n and then the delimiter and like 2 to only say split twice, and then like call next on the iterator twice and then unwrap and whatnot. But with split once, you just have one method that does the thing you want. This comes in handy for things like parsing key value pairs that are separated by an equal sign. Like it's very nice to have this just built in now.
That is pretty nice.
And if you weren't already aware of the rsplit methods and the split n methods, I recommend you go look those up. So rsplit is split from the right instead of from the left, and split n is split but only this many times and then stop splitting. They're very handy to have in your repertoire. So there were also a bunch of functions that were made const in this release, as always. But one thing that was hidden a little bit in the detailed release notes was that all of the division related functions on numbers are now const. This was surprising to me that they weren't already, but I think basically there was some discussion around what should happen if you divide by 0 or take modulo 0 in a constant, because you can't panic because you're in the compiler. So what do? I think the stabilized behavior is just like your code doesn't compile and you get sort of a compiler error that says any use of this value is sort of undefined behavior or invalid. But that's like a nice stabilization that now you can do division, whereas
Yeah.
previously you couldn't.
Well, it wouldn't be undefined behavior. It would always just panic at compile time if you tried to use it. The reason I think so, yeah, it is kind of strange that division happened so long after. Like addition's been there for a long time, subtraction, multiplication. But I think, yeah, first of all, resolving the idea of like what does like the error message look like if you panic at compile time. Like it should give you a nice, well-formatted compiler error. Should be readable, that kind of thing. You have to Rust's usual standards, but also because Rust has had some limited form of expressions in const position since forever, just to support things like if you have const in your file, you can do like 1+1. And that's a bit different from defining a const function that returns 1+1, because they've always just been like different machinery, because back in the day, there was no const fn. So for a long time, you've been able to do like 1 divided by 0 in your const, and it would just panic at runtime. And the idea is that's now becoming a hard error. It's being as a lint right now on by default. If you like have an instance of this, you probably shouldn't. You would know pretty quickly if you did. But it's becoming a hard error. So there are like it is technically a breaking change where something that did compile before because it was doing const x i32 equals 1 divided by 0, that will just stop compiling sometime in the future.
I mean, I think the other big benefit or big difference maybe of const fns is that they don't have to be executed at compile time, right? Like a const fn is something that let's say it takes an argument, right? That is a number or something, and it does like argument plus 1. And that's your const fn. Then if the argument is itself a constant, it can be valued at compile time. But if it's a runtime value, like it's read from the user or something, then it gets run at runtime. And this is sort of the nice duality you get of constant fns, and what also makes them more complicated.
Speaking of compile time, there was an interesting development that happened in this release as well that you won't get from the release notes for 52, but for the point release of 0.1 that came shortly after. So do you want to talk about this, John?
Yeah, so this was Rust 152.1, and it's always interesting when we get these patch releases for the compiler because usually there's some interesting thing underlying there. And I actually thought the 152.1 blog post was really good about explaining what the problem was, why the decision was taken the way it was, and sort of where we go from here. Essentially, what happened was it turns out that there's been a decent number of bugs in Rust's incremental compilation feature for a while, where artifacts were reused when they couldn't safely be reused. And what would happen is like you got a compiler error or a linker error or something, and in reality you would run like cargo clean and then you would build again and then it's fine. But in practice this shouldn't happen, right? Incremental compiles should just always give you the right result. And what happened was they added a check to the compiler that would sort of crash early if it ever detected that incremental compile would do the wrong thing. And the hope, of course, was to fix all of the errors that change would find before the actual change landed. I don't know exactly how this happened, whether it was a lack of communication or whether it was sort of they didn't anticipate that too many errors would be found. But ultimately what happened was in 152.0, this check was added to the compiler, but there were still cases that hadn't been fixed. And so when the release came out, suddenly a bunch of people just couldn't compile their code anymore with incremental compilation because they would just get these internal compiler errors saying incremental compile would do the wrong thing. And it was such a big problem and happens for so many cases that they ended up cutting this 152.1 release, which disables incremental compilation entirely. And this is sort of a controversial decision, right? Because shouldn't you just make it not panic? But the argument is that, well, if we make it not panic, it's still going to do the wrong thing. And so we would rather never do the wrong thing than just hide the panic from you. And so the incremental compilation actually remains off even in 153, but I believe the plan is that for 154 they sort of fix the remaining major issues there. And some people are like, well, why don't you just undo the changes that cause these panics to happen? And in reality, this is just sort of detecting errors and bugs that have been there for a long time. So it's not as though in 151 incremental compilation was just fine. It's just you wouldn't be told about it until something went wrong later in the process, which it didn't always do. You might just end up with a slightly incorrect binary, which in and of itself is a problem.
Yeah, it should be mentioned too that this mode, incremental compilation, was not on by default for release builds. So it's unlikely that any kind of like code generation error actually made its way into any Rust binary. It was only for debug builds where you mostly see this because it affects code generation negatively in general. So it's not really a security concern, but it is not really a thing you want to ever worry about. Debug builds are for debugging bugs in your code, not for bugs in the compiler.
Yeah,
So,
exactly. There were some other smaller things in 152 that I think are worthwhile calling out. The first one is the upgrade to LLVM 12. This is something that probably won't matter to most users, but I think sort of for the people who are internally working on the compiler, this is like an exciting upgrade. Do you want to talk a little bit about the no alias discussion?
Yeah, so I mean, it's a bit, not I won't say controversial. It's been just kind of a bit of a saga at this point. So if you know a little bit of C, maybe you're aware of this restrict keyword, which allows you to tell the compiler, hey, I know that this pointer doesn't alias any other pointer. And this is an important optimization in some cases. So for example, I believe Fortran, every pointer is restricted in this way. And this allows certain kinds of code to be extremely fast. You can have extremely aggressive optimizations applied. So C added this, but unlike in, say, Rust, like it's kind of difficult to really know whether or not a pointer is aliased in C. There's no bar checker, you're kind of just on your own, so it doesn't really get used extremely much in C. It gets used some, but Rust has had quite a lot, but there's obviously support for this in LLVM, and Rust has had quite a long time of trying to enable this by default for all mutable pointers, all mutable references, because that's kind of Rust's whole thing is that if you have a mutable reference, you can't have two pointers to the same thing. They're always unique, and so you should, in theory, be able to kind of like transparently, you don't need any kind of keyword in your code. The compiler should say, hey, I know that this pointer is not aliased, and give me all those sweet, sweet optimizations. And it turns out Rust uses a lot of mutable references, and
who would have thought, right?
Overloads LLVM and finds all kinds of edge cases. I think it was maybe enabled like shortly after 1.0 or even before, and then disabled a bit after that, and re-enabled, and then disabled again, and then re-enabled earlier this year, I think. Yeah, for this release, and then I never made it into stable because people testing on Nightly found miscompilations in their code from having this enabled. So
we should be clear that these miscompilations are because LLVM has just like bugs in how it handles things that are marked as no alias.
Yeah. So I mean, programs have bugs. It's kind of like we have testing to reveal these, and so like the Nightly process worked. Someone said, hey, my code's no longer compiling. I think it's I'm narrowing it down to when you did the LLVM upgrade and enabled no alias for all these pointers. And so actually, in contrast to past efforts, the patch for LLVM, or the fix and problem LLVM, was identified almost immediately. A patch was sent in pretty quickly, accepted, and then Rust had to update, pull in the new fork of LLVM, update its version, and then update submodule, and then get all that stuff squared away. But it only took maybe a month or so for the new Nightly to have the fix, and so this is not enabled again in the next release, 53. And so we won't talk about it until 54, our next podcast. But hopefully in the future, just like with incremental compilation, we will have some shiny new features enabled, fixing old bugs.
I also just think this is a really cool example of just sort of a force for good in the ecosystem of this sort of positive cycle of improvement between the Rust project and LLVM is
Yeah,
really cool to see.
because also if you're using, it's possible, entirely possible. I can clearly imagine that if you're writing C code and you were hitting one of these crashes using restrict, you almost certainly assume it's your fault. Because again, it's pretty hard to really be sure that you're not aliasing a pointer in C, like in every single case. And so knowing it's a compiler bug, assuming it's your fault, not a compiler bug. And so if you are writing C and using this new LLVM version, you will also be fixed. So it's a great example of Rust giving back to LLVM. There's even a blog post in a different capacity. I forget why, but there was a LLVM blog post between like Firefox, LLVM, and Rust. There was a really cool. I forget what the topic was or the actual bug that was fixed, but it was just another. I'll try and find that for the release notes. But it's always great to see projects working together and giving back. Open source. It's pretty cool.
Yeah. Another cool change I thought from 152 was there's a new lint in town. So this is the unsafe op in unsafe fn lint, which I'm really excited about. So this is from, I think, RFC 2585. The basic idea here is that if you declare an unsafe function, then previously by default, and still actually, the body of the function is considered to sort of automatically be an unsafe block. This is sort of nice in that if you declare an unsafe function, you can just use unsafe functions within it without having to explicitly annotate them. But it becomes a little unfortunate when you write longer or more complex unsafe functions, because it's now very hard to tell which parts of the body of that unsafe function are actually unsafe, like which ones rely on things that are unsafe. And so what's changed with this lint, which I think is still off by default, but I think the idea is to turn it on for the next edition.
No, it's not actually the plan. I mean, for the this year's edition or the one after that?
For the one after.
Maybe. We'll see. There's been some talk about that, but go on.
Well, it's true. It's too far off to say. But basically, this lint is going to make it so that if you turn it on, it's going to tell you to add unsafe blocks for any unsafe operations, even if you are inside the context of an unsafe function. And so basically you can think of this as sort of a lint that opts you out of saying that the body of an unsafe function is itself unsafe. I think this is going to be, it's a little bit of a pain if you're just writing short unsafe functions where like the entire body is just calling some unsafe thing. But for anything that's larger, this is going to be, I think, an improvement to the explicitness of what is actually unsafe in there. And that's also the motivation of the RFC.
I can see like projects that have really strict security requirements, like mandating this be on. If you want to have a kind of like really a hardened Rust, I assume this will be like part of the repertoire of flags that you enable, like in this all the clippy stuff. I like it too a lot. It's kind of like unsafe means two different things, kind of like obviously like it means the same thing, like be careful, but like if it's as part of a function parameter, it means that this function should require an unsafe block to call. But like as an unsafe block kind of like means the opposite, where it's like, hey, trust me, I think this works. And
the way I often think about it is the unsafe keyword on a function is a like declaration of a contract saying to call me, you have to promise these things. And an unsafe block is saying, I have checked the contract of all the things inside the unsafe block, and I assert that I uphold them. And those are very different things.
It's just nice too because there's no safe keyword. If like in theory you were to write an unsafe function that had an entirely safe body, like that's not like a thing that I can't really think of right now of a reason why you could do that. But like I mean, it's a thing that should be allowed. Like and like parts of your function too, like obviously can definitely be safe. If you want to have like tightly scoped unsafe blocks, there's no way to say, okay, this part is safe and this part isn't safe if the entire body is unsafe. And so I think it's a good change.
Yeah, I mean, there are definitely cases where you can have a completely safe body too. Like you could imagine an unsafe function that decrements the reference count for an arc. But like that's a safe operation,
That's
but it
true.
might be unsafe in the context of your particular library because of other invariants you're maintaining in the code. And so the function really does need to be unsafe, even though the body of it contains no unsafe code.
Mm-hmm.
I had two other ones for 152. One of those pretty short. They both really are. The first one is that now you can use task lists in Rustdoc Markdown. So task lists are things like you might have seen on GitHub. Like you can have in Markdown like a dash and then square brackets with either an X in it or a space in it, and it gets rendered as like a list of checkboxes. That is just now supported in Rustdoc Markdown as well, which is really nice. And then the other, which I guess is a much more serious change, is there's this magical environment variable called rustc bootstrap, which you probably should never use. It's a, or rather, I should say, you should never use this environment variable. If you are absolutely positive that this is the exact right thing for you to use, then go ask on Zulip whether it is first. Like, be really sure that you need it. It's an environment variable that lets you use unstable features on the stable compiler, which sort of violates all the stability guarantees.
Yeah, obviously, you opt
Rust
out of
itself.
stability at this point.
Yes,
Understand.
exactly. Yeah, like understand that there are lots of warning signs here and you should probably not do this. But it used to be that it was possible to set this environment variable from a build script. And what that meant was I could write a crate that I upload to crates.io or something that uses unstable features but is compilable on stable by setting this environment variable. And this is just really bad because it means I can violate all of the stability guarantees for Rust, even in a published crate, without the caller knowing that this has happened. And so as of 152, that is just no longer allowed. If you try to set that environment variable in a build script, it just gets ignored by Cargo. So it's a good just sort of additional safety mechanism for don't use this, and especially not for this purpose.
I will say that on the issue tracker, I do often see a certain John Who's name always associated with many of these discussions about Rusty Bootstrap. I wonder if he's being a naughty boy using it in his own projects.
Definitely am, but I have asked many people for many permissions first.
I'm telling.
I think that's all I had for the 152, I guess, release series, because it had 2 patch releases.
Mm-hmm.
But then I guess that brings us to 153, which is in and of itself very exciting. There's lots of cool stuff in this one.
Yeah, the coolest thing in this one is definitely the IntoIterator implementation for arrays. So this has been, again, a very long saga. In this case, for the sake of backwards compatibility, I think we talked about this previously. The one, did we?
Yeah, we talked about this in, I think, 150 or 151.
Yeah, I'm not sure. Yeah, that's right. We were talking about like the upcoming release because we were. It's an exciting, fun hack that allows like a thing that is entirely natural. It's a use of const generics where now that const generics are here and they allow arrays to be kind of like more first class than they used to be in terms of like being able to implement things for them in a way that makes sense and is consistent with the rest of the language. Now you can just write, for I in square bracket 1, 2, 3 and square bracket. Whereas previously, to actually iterate over an array, you'd have to either call like .iter or IntoIterator or take it by slice with a ref in front. Now you can just have a by value iterator over an array, which is pretty cool, which didn't happen for a long time because specifically people were calling .iter on arrays, which because of autoref would give you the iterator for slices, which yields elements by reference. So, and you can work around this by calling, have your array .IntoIterator.cloned, which to get the things out by value. And like if you had, if types are copy, it's not going to be super expensive to like get them out. But really, you should be able to just do this. And it's really cool that they found a way to make it happen. Do you want to talk about how they made it happen, John?
Yeah, the hack is sort of beautifully simple. The basic idea is that in the 2015 and 2018 editions, so basically in all the current editions, if you have an array and you call IntoIterator on it, then autoref will sort of take place. So autoref is this, we're going to call it a compiler feature or language feature, where if you have a method that takes a reference and what you have as a value, then it will take the reference of that value for you before calling the method. So this is what enabled, like, if you had an actual array and you called .IntoIterator on it, that led you to get a iterator of a slice of the array rather than the array by value. What they're going to do is basically have that autoref continue to take place for the 2018 and 2015 edition, even though there is an IntoIterator implementation for array, so not for the slice that requires the autoref. And then in the 2021 edition, what they'll do is not have that sort of special casing, so that if you have an array, you call IntoIterator, it will do the thing that will normally happen for any sort of dispatch, which is if the method exists on the thing by value, then use that and only apply autoref if it doesn't exist for value. And so this means that now they can sort of stabilize this impl of IntoIterator for arrays without breaking any code that relies on the fact that you can use .IntoIterator and get a slice. And then still not add complexity to the compiler, but rather sort of remove complexity in the later editions.
Yeah, so it'll be like fixed in the next edition. We'll talk about in a sec. So stay tuned for that. Next up, I have Unicode identifiers. Jon was telling me that he had a need for this just the other day.
Oh yeah, it was a very important need, which is I was doing a live stream where I had to name a type, and naming types is hard. So I decided that for a little bit of fun, I was going to name the type using a Norwegian word. But that Norwegian word had the letter O in it, which is like an A with a circle above it, and it is not in ASCII, which means that the compiler yelled at me and said, you can't use that as the name. And it was very sad. And I had to choose a different Norwegian word that didn't have any weird characters in it, to the viewer's great chagrin. But now, as of Rust 153, you can use Unicode in identifiers. So that is, you can use it in the names of variables, you can use it in the name of constants, and you can use it in the names of
functions,
I guess,
and
fields
types.
And types.
Any identifier position.
Any identifier.
It's not full Unicode, though. It's only, there's a subset of Unicode called UAX31, which defines things that like are kind of like name-like your glyphs that get used as parts of names. So this notably does not include any emoji. So you can't just put random emoji as names of things. You could say, because Greek letters, Greek
this is important,
a thing,
Ben. You cannot
you can't do it yet.
This.
We'll see. But just know that it's not coming anytime soon, if it ever comes. I know that certain languages allow this, like Swift allows this. So
and I think part of the reason is this nice warning that Rust will currently give you if you use Unicode and you use a character that looks an awful lot like an ASCII character. The compiler will actually warn you that like maybe you meant this other identifier that looks similar, but it's actually a different Unicode symbol sequence. And it can do that probably in part because it only uses a constrained part of Unicode.
Yeah, and there are actually, I think, no less than 3 different but related lints trying to warn people against, like, the threat of, like, say, like confusable attacks or that sort of thing. So if you can also, I think, you can just deny it the entire feature if you want with a lint. So you could, if you, like, for whatever reason, if you're like, I don't know, the CIA and you're worried about Russian hackers inserting, like,
very topical,
a Cyrillic A into the arrest code that the CIA uses, you could just be like, aha, foiled you, KGB. The single lint.
Deny those Unicode characters
so
that Jon
safe.
wants. The other feature in 153 that I'm really happy about is OR patterns. So this is when you write like a match, then it used to be that you could only really match sort of one pattern or another pattern. So you could say, let's say you're matching on like an error type, like an IO error. and you wanted to match on like one of, it's actually a bad example. Let's say you're matching on a number, to take something trivial, then you could do like match this number, one pipe 2 pipe 3 would match 1 or 2 or 3. But it gets more complicated if you wanted to do something like, say, you had an option of a number and you wanted to match like sum of 1 or sum of 2. Previously, you would have to like list those out in that way. But now with OR patterns, you can put the pipe character anywhere inside of a pattern to signify an OR in that location. So you can say something like sum paren 1 pipe 2 to say match a sum where the contents of that matches 1 or 2. So this just means you can condense your patterns a lot more. You don't have to repeat the full pattern multiple times. And it's just a really nice ergonomics improvements, I think.
One of the library additions in this version caused some consternation. So there is now a associated constant on the integer types called bits. And the idea is it's pretty simple. It just if you have an integer type, you just call colon bits, and it tells you how many bits are in the type. So good for knowing how big a type is at compile time. Pretty useful. But the problem is that a popular library had already done this and was being used in the wild. And so it was causing an error because it wasn't sure which one you meant. And the compiler didn't know that they were probably the same thing. It just knows that it sees two instances of these names and it says, hey, whoa, I don't know which one to use. I'm going to back off here. And so it's a bit different from the case where, so often in Stud, what is allowed to happen is, or how naming works in Rust is, if you use a thing, if you define a thing locally and you use a thing, your local thing will overshadow the thing that you define locally will overshadow whatever you imported. And so if Rust wants to say add a method to a trait, and then you define a thing locally, I'm not sure if this is a good example, but anyway, the point is in most cases the thing that you define locally just gets used. And so I think one example is if you have a module and you import everything from the module, then you define a thing locally, Rust, isn't going to complain in that case because it knows you want the thing you define locally, which allows Stud to add things over time. Because otherwise, it might be impossible to ever add anything ever anywhere in Stud, right? In this case, though, this is not a case where the compiler understands hey, we want the local thing, or even it's you have just two libraries both defining the same thing. One is Stud, yeah, but still, it's still a library. So what should happen? And it's kind of people wondered for a while, is it, we, as usual, whenever a thing like this happens, the usual approach is, okay, we're going to send out patches to every library that uses this library as a dependency. We're going to, first of all, fix it in the dependency. Then we're going to ask them to update, and they backported it to every single major version of the library so that anyone on any version only needs to ever do a cargo update to have it fixed. But still, there's always code out there that never gets updated. And so how do you deal with that? And so I think eventually they just realized, okay, well, this is just we have to be able to add things sometimes. We've done our best to mitigate this. We can't do it over an addition, so we're just going to add it. But it's an interesting example of trying to evolve a library when users can do anything and define anything. How do you just deal with that? How do you there's always this tension. And so every language has this problem too, where people talk about Java being enterprise, C++ being enterprise ready. But if you ever look at a Java release, say, there's always a huge compatibility guide of things that have changed, either slightly in behavior or sometimes even been outright removed. So it's a tough problem making a language. The problem is the users, really.
It's interesting too, because this I think initially no one really thought that this was going to be a problem. So it almost landed in an earlier release. But then someone caught it on Nightly and was like, this broke my compilation. And so they sort of reverted it and then worked with the ecosystem to try to get rid of the conflicting uses and then tried to stabilize it after all. And it's it's like, as you say, it's a weird, complicated situation, right? Where you don't
Mhm.
want the standard library to stagnate completely either. So you sort of want to have some of this collaboration with the ecosystem, but it's a challenge because not all of the ecosystem is necessarily available to you. This is where things like Crater comes in really useful, but currently you can't really do a Crater run to test whether a change breaks all the code the companies use, for example. It's a difficult problem.
The problem is too many folks use Rust these days. Like if no one used Rust, then they can change whatever they want to, right?
Exactly. There's some other cool stabilizations too. Off the top of my head, like the B tree retain methods is nice. So this is something that has existed on vectors and hash maps for a while. Retain is just a method that you give a closure, and it gets called for every element in the collection. And if you return true, then the element is kept. If you return false, then it gets removed. It's a really easy way to just sort of filter down the elements in a collection, rather than like turning it into an iterator and then filtering and then collecting back into a thing, which can be much less efficient. And that has traditionally been missing from the B tree data structures, but that's now been added. Durations now have a method called is0 that you can call to determine whether this duration is 0. Whereas previously you had to compare it against like a duration : new given two arguments of they're both 0. It was just really awkward to construct a 0 duration. And now you can just is0. It's very handy.
One of the minor changes released, what I thought was interesting, was in Rust's handling of parsing and printing floating point numbers. In particular, being compliant with the floating point spec, which is kind of, it's always a rabbit hole. The floating point spec is large and subtle. And in this case, there were a few cases where Rust was not in compliance with the spec. So that's been fixed, as far as we know. But interestingly, this means that it's a slight behavioral change where if you had a value that was -0, and yes, there is -0 in floating point, it would print it as 0. And you might be thinking, well, isn't that what you want? Well, I mean, semantically, it is usually the same thing, usually being the keyword because, floating point numbers sometimes does matter. But the idea is that the guideline is that numbers should be able to round trip. And the idea is that if I print out a number and then reparse that printed number, I should get the same thing back. And so, as you might expect, if you just have 0, you get the bit pattern for 0 if you parse that. And if you have 0 as a string, say, and then parse it as a float, you get the bit pattern for 0. But 0 and -0 are different things, and so you wouldn't, if you had -0 printed as 0, you get the wrong thing back after you parse that. So that's just one of those interesting little float quirks. And speaking of float quirks, I know Jon is just dying to tell you about this rabbit hole that he's found.
Oh, just absolutely dying. Okay, so brace for this one. So there is a stabilization of a method in the standard library called isSubnormal. This is a method on F32 and F64, and it tells you whether a given floating point number is subnormal. And if you don't know what is subnormal means, well, you're not the first. And indeed, I had the same problem and had to look it up. So subnormal is basically a sort of alternative representation for floating point numbers that are very close to 0, where you set the exponent to 0, and then the bits of the floating point number get evaluated in a slightly different way that gives you less range for which numbers can be represented by it, but gives you more resolution close to 0. And as far as I can tell, subnormal floating point numbers are often not supported by the hardware. They're often much slower. I don't know exactly when you would care whether a floating point number is subnormal, but now you can. So that's good. It's one of those fun things where when you're writing a general purpose programming language that's also designed to work for really sort of low level code, then things like this just matter. People need to be able to check for all these weird representational things. And I guess isSubnormal is now one of them. Another interesting implementation that I saw that I was sort of scrolling through, was like, what does this mean? So in 153, there's an implementation of slice index for tuple of bound usize. And there's a lot of unpacked in that sort of implementation. First of all, there's the slice index trait. So the slice index trait is a trait that describes types that can index into a slice. So that sounds complicated because it's a little bit weird to think about. But the idea is that if you have a usize, it can index into a slice. If you have a range, then that range can index into a slice. And now you can also use a tuple of two bounds, which is often how you construct a range in the first place, right? So you could say a tuple where the first element is 0 and the last element is unbounded. You can use that to index into a slice to get everything from 0 and onwards, for example. So it's sort of an alternative representation for a range. And you can now use that as the index for slices, which I don't know if you ever have a use case for it, but I thought it was interesting to sort of unpack why it's even a thing and what it means. Because sort of stuck out as the longest thing on the list of stabilized APIs. I had another couple of smaller things from the changelog around cargo. The first one of them is that cargo will no longer assume that the default head of a Git repository is named master. This is sort of in line with the change that GitHub and other repositories have been making of moving from master often to main. And that will now just work in cargo. You don't have to specify like branch equals main in your cargo.toml. It'll just use whatever the head of the repository is. So that's a nice sort of ergonomic improvement for things that don't use master. 153 also landed RFC 3052 in cargo, which makes it so that the author field of cargo toml manifests is now optional and will not be generated by default when you run cargo new. And the idea here is that it's both sort of an issue for leaking personal information somewhat accidentally, but it's also so that if you want to sort of change your name or remove your name from the internet in some meaningful way, now the crates.io team has sort of a mechanism for doing that, or you have a way to do that when you're publishing crates, which is just to remove it from the cargo toml because the field is now considered optional. So that was a nice improvement, I think, that landed in 153. There was also a cool change to rustdoc, which is you may be surprised to learn this. In Markdown, if you just have a URL that doesn't have any sort of syntax around it, it doesn't get automatically turned into a clickable link in the render documentation. That's actually you can do this on GitHub because it's a feature that GitHub supports. But in general, in Markdown and in rustdoc Markdown in particular, those kind of bare URLs are not rendered. And in 153, there's now a lint that will tell you this. And if you've written a lot of documentation for your crates, which I hope that you have, you will probably see this lint crop up a lot. I know I did, where now if I compile with 153, I get like a screen full of warnings saying all of these URLs are not clickable, and then sort of suggesting the syntax for making them clickable, which is just, I think, put angle brackets around it and that will happen. But this is like another way to sort of gently and slowly evolve documentation to make it more pleasant to consume. I think that's all I had from the sort of detailed release notes too. Did you have anything else, Ben?
That's it for me.
I think that brings us to the proposal for the next edition. It's a big change.
Let's go over real quick what an addition means. The idea of an addition is that it's an opt-in change to like some parts of Rust that might be backwards incompatible. So the idea is if the language wants to evolve, like we talked about the bits change recently, and that for whatever reason couldn't be an addition change. But we'll talk about some things here where adding things to stood in certain ways would have been a breaking change. And rather than just go ahead and do that, the idea is to mitigate that by saying, hey, if you want this, you have to opt in to this change. And
so Ben, are you telling me that this is just Rust 2.0?
No. Because here's the crux. Here's the essential difference. Like people learned a lot from the Python 3, Python 2 split, and crates from any edition always work together because fundamentally they're all just the same code underneath. additions only ever kind of like exist in like the very frontiest front end of the compiler, right? So there's no code generation difference, there's no backend difference, there's no like really even any kind of like optimization or middle end difference in terms of like how the compiler like understands how the code works or is structured. It's all just surface level kind of like cosmetic-ish changes. As deep as they can kind of like get a little bit deep sometimes, which we'll see. But mostly it's all just things that kind of like get tweaked and moved around a bit. And the idea is if you don't want to use them, you don't have to. You can just like remain blissfully unaware and use your current stuff, because almost everything lands in every edition. You don't need to stop using your edition. If you want to still use like the original Rust as it was like in 2015, you can still do that. You can do that this day, and you always will be able to do that.
But you almost certainly do not.
You do not, and you shouldn't, but you can.
Yeah.
And like won't be a problem because there's no like you can still upgrade your compiler without fear. You can still use libraries that use new stuff. So it's a pretty sweet solution. And so it's happens every 3 years or so, and it's about time for the new one. And the last one was pretty big. This one's going to be much smaller. The last one had like a lot of like headline stuff, and it was the first one in ever editions. And they had they had a brand new shiny toy. They wanted to like advertise it and be real big and kind of like put it up as a big like a marketing event for Rust. We're talking about like everything we've done for the past 3 years, and since then it's kind of been like, well, actually we're pretty good at just talking about things like as they happen. So this is more of a low key edition. No like real huge headlining feature.
Yeah, and I think it's easy to sort of understand what the edition means when you like this blog post. I thought was really well written, and I think just seeing the kind of changes that happen too on an edition boundary helps a lot in understanding the kind of things that they can change, and sort of by exclusion the kind of things that they can't.
And we should mention too that if you ever like the standard way of making a new project in Rust is like you type cargo new or cargo init if you're already in the repository. And it just like adds your cargo toml, and the secret sauce, the magic, the final like magic sprinkle of this is that in the new edition, any new crate always begins with the most recent edition. So like the ecosystem gradually moves forward as folks write new things, even without like having to opt in their old stuff. So yeah, and let's get into some of the changes. Well, there's not too many, not too major, but they should be pretty nice. First up is new additions to the prelude. So in Rust, the prelude is sort of, you can imagine, you've written Rust before.
What?
You don't
no, I
to,
haven't.
You haven't? Oh, well, let me talk about it. It's written language. It's super safe and super fast.
Rust
super
isn't
cool.
that a game?
Well, it's actually. It is both. We'll talk about later, maybe in a future episode. So the idea is in a Rust program, you don't need to write a hello world. There's no like, fn main, println, hello world. You don't need to import println. You don't need to import many various things that are fundamental to many Rust programs, stuff like option, stuff like vec. It's always just there lying around ready for you. And if you know the module system, that you can like type like, use crate name, : star. And there is effectively, in every Rust program, the line at the top, kind of like hidden, is use stud : prelude v1 : star. The v1 just kind of being, like forward thinking. It's invisible. Who cares? The idea being that this prelude is what gets brought into scope in every Rust program. And so normally it's not a big deal to add things to the prelude because, as mentioned before, Rust, if you define a thing locally, it'll take precedence over whatever you import. So they can add things there, like types, for example, without problems. Like so right now, hashmap, for example, is not in the prelude. But if they wanted to, they could add it without an addition just whenever they wanted to, and it wouldn't be a breaking change. But for traits specifically, the idea is if you're calling a method on certain things, then the method might become ambiguous if they added a trait to the prelude. So this new addition, or the addition to the addition, is that 3 traits widely requested are being added to the prelude, available only in the new edition. They are try into, try from, and from iterator. And so try into and try from are just the counterpart to the into and from traits, which are already in the they're in the prelude, right? I'm pretty sure those are already in the prelude.
Yeah, they are.
which lets you say, yeah, definitely are, because you can do x equals string colon colon from, and then a string literal to make a string. So now you have like this for anything that is not an infallible conversion. And then from iterator makes sense because IntoIterator is already in Prelude, because it's what lets you kind of use for loops pretty much, and it's kind of just the reverse. And so it's very useful for taking the thing that's already an iterator and turning it into it's how collect works. If you've ever seen a long iterator chain and then dot collect, this lets you just use from iterator directly, which powers collect under the hood, which is useful in a bunch of contexts.
Yeah, it can also make it a little bit nicer to write certain types of generic code where the annotations get a little ugly if you have to use dot collect. Whereas if you can use from iterator, you can you get to turn the chain around, and sometimes that restructuring makes the code a little nicer to read. The other thing that's on by default in the 2021 edition, or will be on by default, is we talked, I think, in the previous episode on Rust 151 about Cargo's new feature resolver, which you can activate currently by setting resolver equals 2 in your cargo.toml. And in 2021, or in the 2021 edition, I should say, that resolver version will be the default because it's just better. Like, you should just always use this, but it's backwards incompatible for any given crate to switch it from 1 to 2, because now your features mean slightly different things, and your dependencies are compiled in a slightly different way. But because the addition is an opt-in anyway, it's totally safe to say if you opt into the addition, you're implicitly also opting into the resolver. That's a totally safe transformation to make at an addition boundary.
We also already mentioned the IntoIterator for arrays change, and how there's this kind of very specific targeted laser targeted hack which allows code that exists currently that calls some array dot iter to still function, even though nowadays that should give you the by value iterator and not the by ref iterator. So that hack will not exist for any additions prior to 2021. So all the code will keep compiling, but now in the new edition and beyond, it will work as you expect. If you're writing like new code that uses iterators, and remember that also you don't need to normally write dot iter. If you're doing things with arrays and iterators, you could also just use it as in a for loop to say for blah in the array. Or there are definitely other contexts where you can just like make an iterator without using dot iter. So it's not even the case that like this is usually a problem, but it will become
it's only in the
consistent
specific case of using like dot IntoIter as a method on an array.
I think just dot iter is the problem. I think dot iter, maybe? I'm not sure.
No, dot IntoIter is the problem.
Okay.
Dot iter has always worked because it always gives you a by reference iterator.
Okay.
But dot IntoIterator on an array gives you a by
right.
value one. The next one is, and this is, I think, a big one for me, is that in the 2021 edition, closures are going to capture only the specific fields that are moved into them. So if you have a struct that has two fields x and y, and you only access like struct.x inside of a closure, and let's say you have a type a that's an instance of that struct, and you access like a.y inside the closure, but you don't access a.x, then the closure will only move a.y into the closure and not a.x. This is a really good sort of quality of life improvement, or rather, it's just less surprising to users, I think, where previously you would get these like unfortunate borrow checker errors that are really annoying to work around. If you say like drop or move a.x and then you try to use a.y in the closure, it like fails, and you have to like assign a temporary variable the value of a.y outside the closure and then move it in. It would just require these awkward workarounds that are hard to discover. And in the 2021 edition, finally, closures will only capture what they need. And so those kinds of weird errors or warnings from the compiler will no longer happen. And that's really nice.
This next one we spoke about last time too, I believe. It's panic macro consistency. The idea being that there's a new feature incoming sometime this year, hopefully, which allows you to implicitly capture formatting arguments from the environment. And so if you're used to string interpolation from other languages, you're used to probably writing kind of like in your string literal have like the name of some variable, and it just kind of like plugs it in right there with no more ceremony needed. And so that is coming to Rust in limited form later on. But while doing this, it was noticed that the panic macro wasn't actually, in the case of a single argument to panic, it wasn't actually properly forwarding to the format args method. So like if you had panic of just a string containing some braces, it would not interpret that as a thing to format. So that was inconsistent with all the other like print line and so and so. And so there's been some shuffling around where like the panic macro will now do this, but there's now a new macro called panic any for the old behavior and so on. And so that's just moving forward by default in the new edition.
Yeah, and I think panic any is actually it's a function, not a macro, specifically for this reason.
Mm-hmm.
And then another one is reserving syntax. So the idea here is it doesn't actually change any behavior, but essentially what they're doing is saying we're going to reserve the syntax, like some prefix followed by either a pound and then an identifier, or followed by a string in double quotes, a character in single quotes, or a number. So this is something like, you've already seen this if you've ever written like a byte literal string. There's something like B double quotes and then a string, which gives you a slice of U8s, like a byte string, rather than a Unicode or UTF-8 encoded string. And this sort of reserving this syntax of anything that matches this pattern of prefix and then pound identifier or double quoted string and so on, means that later on, without an addition boundary, they can add support for more prefixes. So currently there's only, I think, B for byte strings and byte cars, and R for raw, so uninterpolated strings. But you could imagine that you want to add additional prefixes in the future for things like a shorthand for format strings, or for null terminated strings, or for like using a keyword like async as an identifier, like the name of a variable. But those things would all require addition boundaries if they made it so that if they added a new prefix, because the general syntax of, say, K pound keyword would not be reserved. But now they're just like blanket reserving anything that looks like this, so that they can add these prefixes later on without that requiring an addition boundary.
Yeah, I am qualified to talk about this because I wrote the RFC for this actually.
Oh,
so,
nice.
Yeah, you may be like, so the actual syntax here, like you from the previous edition, 2018, the idea was, you mentioned like you want to be able to actually write, you have code that maybe has async as an identifier, and Rust wants to use it as a keyword. And so now there's this thing called raw keywords in the language, or raw identifiers in the language, which lets you just like use any keyword as an identifier by having this R hashtag in front of it. And it's funny because the reason that was chosen is because that was already, it was a like syntactic construction that was already just by chance a syntax error in all versions of Rust, just because it was trying to like, it thought you were trying to like parse a string. So because of that, it could reserve this syntax. And so we're kind of expanding that, the hashtag syntax, to other things potentially. And so one of the previously proposed ideas for the addition was a kind of a K hashtag identifier, which kind of does the reverse, which lets keywords be used as identifiers. And it's kind of like, there's no actual use for that yet. But the idea was, well, it's an addition, so we have to, like, it would require a change to do, so we'll just do it right now. But the idea is we don't actually have to do that right now. We can still, like, there's no time pressure, there's no crunch. We can just like reserve the syntax now and then like worry about the details later. And the same thing for strings. And so, like I mentioned before, format strings, like Python style F strings, for example, or a big inspiration for the current implicit formatting arguments. And so, like, at some point, people might want to actually move towards having actual F strings. So that's now a possibility. Again, just a possibility, nothing guaranteed yet, but also it allows things like, say, if you wanted to have like just actual like string, like capital S string literals, you could have those, having maybe like an S prefix on there, a C or like a Z for like C style like null strings. It's also like the bytes have it, or sorry, the char literals have it too, and also numeric literals have it. And this is actually it's funny because the exact same syntax that Rust uses for these raw keywords, the hashtag, gets used by like languages like Ada and various other languages to denote like prefixes, usually for the choice of what radix the literal should be in. So I'm not sure. Like maybe like there could be like, I don't know, wrapping string literal or wrapping integer literals or like that kind of thing someday. So, but these are great. These are all just
An
like
encryption prefix.
yeah, like secrets.
Yeah.
Or yeah, that could be a thing. Maybe even user defined someday, like overloadable. But the idea, normally almost no code ever actually needs to worry about this, and so you may be wondering like, why does actually feel like condition change? And so the idea is that macros that consume like syntax, like token by token, previously could observe the difference, and they might be broken by this. And so because macros consume things per token, actually you can fix your macros if you have this by just putting in white space anywhere in this to like force it to be tokenized separately and not as a single like prefixed literal or whatever. But it's still like it's an incredibly like unlikely and minor problem to like actually affect anybody, except maybe if you already have a crate giving you like f strings, say, in macros.
Right, but the nice thing here is the addition boundary lets us not worry about whether it might be breaking and just say on the addition boundary we're allowed to make this change.
Mm-hmm.
And in fact, sort of talking about macros, that's also the motivation for another addition change, which is we mentioned OR patterns earlier, right? And when you write a macro definition using macro rules, there's this like fragment specifier called pat for a pattern that matches anything that is a valid Rust pattern as its input. And one thing that they had to do when they landed the support for OR patterns is that a pat fragment specifier in a macro rules does not match anything that includes an OR. And the reason for that is because those can't necessarily, like if you were to match them, those patterns can't necessarily go anywhere patterns can go. That is, there's still some places where you cannot use OR patterns, and so you don't want the macro to match an OR pattern when it can't necessarily go there in where what the macro expands to. And so they can't change what pat means within the current edition. But across editions, they can. So in the 2021 edition, pat will match OR patterns as well. And then there will be this like pat param fragment specifier that can be used to match anything that doesn't include an OR, that can be used if you specifically don't want to match them. But it would, of course, be a breaking change to change what pat matches now. But the addition boundary lets us do it.
And then finally, there were people who were around for the previous edition change will remember that some things that used to exist became warnings, some syntax. So in particular, you used to be able to just, or you still can, it's not an error just yet, but it used to not give you any kind of guff for just using a trait object without the din keyword. And so you could just kind of like say, like, if you want a trait object, you just say like, hey, the name of the trait, and that's just now a trait object. And so like when impl trait was coming around, it was kind of like, well, do we want to like really privilege like dynamic stuff over static stuff here? Like who should have the keyword and who shouldn't? And so I think in the future, it's going to be just that, like, if you want dynamic dispatch, you need to use the din keyword. Static, you need to use impl. And like there was talk like years ago of like, not requiring the impl keyword if you want to have like, a statically dispatched, like kind of like a, type for returning or as inputs to a function, which I'm not sure will happen, but it's just the case that now it will require the din keyword in the new edition if you want to dynamically dispatch your traits. And similarly, in Rust 1.0, it was kind of like they weren't yet sure about the syntax of inclusive ranges, where like some languages have like 3 dots meaning one and 2 dots meaning the other, and so eventually it was chosen that to use the dot dot equals syntax for inclusive ranges, as opposed to the just plain dot dot for exclusive. But there had already been stabilization for using dot 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 in pattern position. And so that's been deprecated since the previous edition, and that will now become a hard error in the future.
I think the big question on everyone's mind now, Ben, is, but when will I get this edition?
Sometime in 2021.
Nice. I think the goal is Rust 156, but as this blog post points out as well, like Rust is a project that's run as an open source project mainly by volunteers, and so there aren't really hard deadlines. Like 156 is the goal, but that might slip either for sort of personal reasons or for technical reasons, and it's all fine. The hope, though, is that it will land in 2021. Otherwise, I'm guessing the name would change.
And I believe the current timeline does include a period of like open and public testing in July. So I'm sure they'll announce that. So keep an eye on the Rust blog. And then if all goes well, it should be running the trains by end of July and out sometime in September or so, I think.
It's very excited. I'm very excited.
Yeah.
Are you excited, Ben?
I am thrilled. I'm just bursting with joy.
Well, I think that's all we had for this time around. So I suppose all that's left for us to do now is just sort of strap back down in our chairs and just conserve energy until the next time.
I'll be here. I'm going back into stasis. I'm hibernating. I will set my alarm for 6 weeks from now.
It's going to be great. I'm already looking forward to being able to stretch my legs again.
That said, let's play the outro. It's nice seeing you again, Jon.
Likewise, Ben. And I will see you in 12 weeks from now.
All right, and see you too, folks. Good night.
Bye.